Hi, I built an AI agent to organize files so that I don't have to spend those efforts in cleaning up my drive. Let's take a look at a messy drive. So if you see here, some of your personal identification cards, your bank statements just fallen in the document folder, and your downloads has some image file, which is basically your minutes of meeting incorrectly named to an image. And Uh, Also, there is some setup tool, some installers and extracted. Then there is, so if you see here, there is a picture and there is one picture here, file here, and the same file is also here, but with a little slightly different name. So this is like a real drive, and this is what just happens naturally over time. Sensitive files co-located with receipts, and one file named like a photo but containing meeting notes and installer folder nobody deleted. And there are also duplicates of the same image. And ideally, we would like to get into this state, a clean drive, the same files, what I showed, the duplicates removed, and every file in the right place, the receipts, the notes, if you see the split by year. And so we like to have it organized like this, something like this. Right. And basically the agent did the analysis. When I say the AI agent, and let me pick a good run. I've done multiple runs. Okay. So if you see, this is a DAG, and uh, this is the graph that the AI agent builds. So given a user query, so this is my user query here. And all I asked it to do is analyze and organize this folder and some instructions along with it. So if you see here, you'll have a planner node. Um, yep. So this planner node took about 5 seconds to understand the problem, to break it down into the statements. If you see here, this is the 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 system prompt and the user prompt that we give to the planner, and it calls the LLM, and the LLM gives it returns it with some instructions as to how to proceed, and based on the output of the planner, it oops, sorry, based on the output of the planner, if you see here, there are multiple classifiers and nodes that are running. So basically, these pattern analyzer analyzes different types of files parallelly. And if it were to do like how I was trying previously, all these tasks would have been stacked one after the other, and the wall clock would have just gone blown up sequentially. Now that it's happening in parallel, the slowest node is the maximum time it takes. So sometimes, as I said here, there are some banking statements, etc. And in such cases, the AI agent understands that, okay, these looks like some sensitive files, and there are some sensitive detectors here. So there's a skill defined in my YAML file, which I'll be showing, where it avoids reading the content of the file. It just goes by the name and some basic metadata of that file. In this case, I've just used an cloud API itself, but when in the real run, I'll be using the local Ollama to kind of, so here, if you see, I'll be using this local Ollama to read such files so that the data doesn't get leaked to the cloud. Okay. Let me show another use case. So here, so the critic is like a quality gate. Every analysis that is done, the critic is the role of critic is to analyze that whatever the pattern analyzer or the classifier has done, is it proper or not? Again, there's a system query and there's a user query here which is given to the LLM, and then the judges within this graph itself. It says that okay, I expected some classified list of files, etc. In this case, if you see the critic failed, okay, and it checked the classifier and it failed, but then it automatically heals, itself heals. It spins up a new graph, and so here, if you see, this one failed, and it again spins up a new graph, and then it carries out the execution. Um, yeah. So if you see here, it's not shown here, but this is the node which heals that. So your parallel nodes are not in jeopardy, even if one of them responded. The response was not satisfactory. There's another node which spins up and carries out the task. Though again, back to the skills. So all these nodes that you saw there are maintained in a YAML file here, the agent config YAML file. There are several skills here, the planner, retriever, researcher, and each of them has its own role. So if you see here, for example, the classifier, and what the classifier needs to do is within this classifier, the prompts folder. And let me also show that the prompts here. So these are all the instructions for each of those roles. So here I define what this classifier skill is all about and what are the rules, the do's and don'ts. So this is what uh, is given in the runtime when it identifies that, okay, this needs to go to classifier. These are the system queries that it takes in. Now, here back to the dashboard here. Um, yeah. So in this case here, so if you see the final output is here as to what this drive organization analysis came back with. And if you see here, it says the 19 files scanned, the four were flagged the private, then there are two duplicates and some folders that it skipped. And it also gives a comment as to, with a confidence rate, how well my files are organized and what are some improvement areas, etc. here. And if there is something that I need to be checking on, it also suggests that. And it also says that, okay, what are the sensitive files it didn't kind of look into the file as such, but it kind of sensed it. And also there is also hash file checking also. The hash of the files are also checked for duplicates. I'll come to that soon. Here, if you see, there is like a compare plans. It gives a suggestion as to kind of better organize this. There's a minimal, medium, and best plan. You can choose whatever suits holds good for you. There is also the file filters, etc. here. And if you go back to the dashboard here, there's an option to approve this medium plan, and it will. That's how it takes an action to clean the messy drive into a clean drive that I showed. And no, if I need some more improvements, etc., again, I can give some feedback for it to work on. And if I need some more help to choose, right? Like all these kind of assistants are also available. Now, like breaking down this, like how I started, this is not how I initially started. I started off with some small queries in the beginning. For example, the query was just a say hello. Then the planner node uh, gets this query, and then the output it says that okay, user wants a greeting, so directly format the response, and the formatter is responsible to give me this a greeting. Hello, how can I assist you today? And similarly. I, I just increase the complexities of this queries. Here, yeah, let me take this. So here my query is again like go to this website and give me some details of this person, and I get the final output here, right? And this is how it's planned. And yeah, again increasing the complexity slightly more. I've asked find the population of London, Paris, Berlin, and tell me which are two closest in size. Right. So if you see this here, this is a planner node, and because the planner node says that, okay, you need to find population of London, population of Paris, population of Berlin. So each of these are like one other node here, and these carry out their analysis parallelly. And if you see here, the wall clock time is just 80 seconds. Otherwise, if they are not parallel, it would have been sequential and would have taken double the time, right? And similarly, again, increasing the complexity a little more here. So again, the user query here is to read non-existent path just to see how it behaves. And finally comes back with the file not found because that path is not there. And again, to check if that file exists, there's a sandbox executor which looks for that file, and it is prompted to res respond with a user-friendly message. And again, if I'm running this and suppose this abruptly stopped, it has the ability because we persist this data internally, very frequently. It has the ability that, okay, I've encountered an error here. It needs to just start from here rather than carrying out all the analysis from start. And then it gives you the response. So this was the user query here. Again, compare population of three cities and some analysis on that, and the answer it gives us here. So this is like a learning project. The demo drive that I showed you is a tiny one, and the files are also like just like placeholders. But I do have an actual 2 TB drive at home that badly needs some organizing, and that's my next step. I'm hoping to run this on all the real files and see how far it goes. Feel free to share any feedback. Thank you. Good day.